Okay, so today we have the binomial theorem. Um, this is a theorem that we use a lot when handling binomials. Um, you can kind of turn binomials like a plus b to the power of n, or n being the exponent, into a sum of terms, like using coefficients from Pascal's triangle or combinations. And yeah, it's a shortcut for large exponents, so you can avoid like tedious FOILing. So today we're going to explain how to do this. First is first, the formula, um, the man, the myth, the legend. X plus y to the power of n is the binomial that we're talking about. Sometimes n equals higher exponents like 5, which can get really annoying and very tedious. And even when it hits the 7, it's really, really annoying. You can technically do it, technically, but it's very, very annoying. And I kind of wrote out an example down here for you guys, what that would look like. So as you can see, very long, very annoying. This is just 5 and 7. Sometimes you're going to handle binomials that are raised to the power of 10. And you're gonna have to do all of this. So as you can see, as I increased in my exponent from 3, 5, and 7, it got way longer. So that's what we use our buddy here for. So he does look a little bit scary, but do not let him intimidate you, okay? What we're gonna do first is we're going to kind of break down what this formula is, and then we're gonna use it in practice. So first we have the sum of. Now, some of you might have not seen the symbol before, some of you have. That's perfectly fine. It looks kind of scary. It looked scary to me when I first saw it, but it is not scary at all. What it says is we're going to find the sum of, so sum being plus, we're going to find the sum of a certain number, right? From 0 to the exponent. It's really easy, isn't it? So yeah, it's gonna kind of give you a range of what you can work in. So from 0 to your exponent. So sometimes your exponent equals 2. So it'll be from 0 to 2, right? So now the next part. So what we have here is a little something, it is the binomial coefficient, all right? So our binomial coefficient, what is it and what are we doing? What it is n, right? Choose k. So what this right here says is n choose k. It's kind of just a term that we use, and it means this right here. So it means n factorial, which is, I'll show you later what that means, factorial, if you don't know what it means, but n factorial over k factorial, and then n minus k factorial. So we're hearing factorial a lot, but what does it actually mean? Well, I'll show you. So let's say that we have, we're gonna say, I'm gonna try to pick an easy number here. We're gonna have 5 choose 3, okay? So now we plug in our variables, and that is 5, excuse me, 5 factorial over 3 factorial, and then 5 minus 3 factorial. What does this equal? Well, this equals, sorry about that, 5 times 4 times 3 times 2 times 1. So very easy, just 5, 4, 3, 2, 1. Very, very easy stuff. And then, as you can guess from the numerator, our denominator 3, it's being separated here. So these are 2 different factorials. Now we're going to have 3 factorial, which is just 3 times 2 times 1, very easy. And then 5 minus 3 is 2. And so we're going to have 2 times 1. That should be pretty easy. And something I like to do, you can just multiply this out. This is a very easy scenario right here, 5 choose 3. But something, a little thing I like to do when the numbers are bigger, and sometimes I have to use a calculator, is cancel out like terms. So that means that gives us 5 times 4 over 2, or 1 times 2. And that is a very easy one. You guys can probably already do it. What I'm going to do for you guys is equal to 10. So, very, very easy. Do not let unknown things scare you guys. I kind of wrote it out here for you. This is the binomial coefficient. So, we've taken down the sum, we've taken down the binomial coefficient, and the easiest part right here. So, this is just x n minus k to the power of n minus k, y to the power of k. We're just going to be substituting variables here. Very, very easy. So let's go into a worked example. So today the example we're going to do is a little bit easier one. We're going to do one easy one and one hard one. So I can kind of teach you guys how to, just the fundamentals of it, and then later we're going to do a little bit more difficult one. It shouldn't be too difficult because of course this is not that difficult in general. So we're going to start off with a plus b, right, to the power of 3. Now, remember our formula, this is going to be sum of, sounds kind of disgusting, but it's fine, of 3, oh, I don't like that 3 at all, of 3, right, to, or 0 to 3. I should have wrote the 0 first. But as you guys know, as I said, it's from 0 to 3. Now, we're going to do 3 choose k, because that is our n, right? Our n here equals 3. And then we're going to do a 3 minus k, all right? Hey, looks nasty. Sorry about my handwriting today, guys. Uh, from b to the power of k. Okay, so this is what we're going to do. We're going to do the first one, because as I said, it's the sum of, right? It's the sum of 0 to 3. So that insinuates we're going to be doing this 3 times, okay? So the first one is going to be 3, choose 0, all right? A 3 minus 0. So as you can kind of see, we're replacing our k that's up here, we're replacing it with the numbers we've been assigned. So the numbers we've been assigned is 0 to 3. So we're going to do 3 minus 0, right? Then b to the power of 0. And like I said, this little symbol right here, it means the sum of. So we're doing plus. Then plus 3, choose 1. And same thing, a to the power of 3 minus 1, right? And then b to the power of 1. And then the sum of, so plus again, 3, choose 2. Then a to the power of 3 minus 2 from b to the second power. And you guys can kind of see how it's really just plugging in numbers. This one is pretty easy, but you'll definitely find harder ones. I mean, I definitely have been through some harder ones, but this is much easier than the example I showed from before. So this is it right here. Okay, this is what we have. It does look like a lot. It looks disgusting in my opinion. I would throw it out the trash can if I could, but I'm here to teach you guys. So this is what we're gonna do first. We're going to break them apart in little little groups. So first group, we have. Oh, before I start, I actually wanted to say you can kind of see here, I'm going to highlight this for you guys. You can kind of see that, like I said from before, our sum is telling us from 0 to 3, right? So first we start off with 0, right? Right here, 0, 0, right? And then from 0, we go to 1. So 1, 1, 1. And so then from 1, we go to 2, 2, 2, and 3, 3, 3. So what we're looking at here is we're basically just following what the sum told us to do. We go from 0, right? From k equals 0 to k equals 3. And that's pretty easy. And that's why I just want you guys to remember. So the first one, what does it tell us? We're going to simplify the first little group we have here. 3, choose 0. So for those of you who don't know, 3 choose 0, it's you can calculate it yourself if you want to, but I already know it's 1. So 3 choose 0 is 1, and a 3 minus 0 is a to the power of 3, and b to the power of 0. So b to the power of 0 is 1. So what we have here is 1 times a to the power of 3 times 1. Pretty easy. Then we're going to do the second one. So I'm going to write these down here so we can go back to them. We're going to add them all together when we have them simplified. So the next one, this one right here. This one is 3 to 1. So that is 3, right? Times a to the power of 3 minus 1. That is a squared times b to the power of 1, which is just b. So this right here equals 3 times a squared times b. Now we cannot simplify this anymore. So we're just going to actually no, we can't simplify it. Okay, so now we're gonna do the next one. This one right here. So this one's very easy as well. 3, choose 1 is 3. All right. Then we have a to the power of 3, or a to the power of 3 minus 1. All right, so 3 minus 1 is 2, so a squared times, I should probably insinuate that it's being timed, b. So what does that mean? That means this equals 3a squared times b. Pretty easy, I must say so myself. So now we're going to add this down here, 3a squared b. That's 2 down, 2 more to go. We're going to simplify this one right here. So 3 choose 2, right? I do know that one as well. It is also 3. And now we have a to the power of 3 minus 2. A to the power of 3 minus 2 is 1. And then we have b squared. So this right here is going to be 3 times a, because a to the power of 1 is a, times b squared. So what is that right here? We're going to be adding, down here we're going to be adding 3ab. Pretty easy if I say so myself. Now, oh, I forgot the little square, my bad. And then the last and final one. So we have 3 choose 3, which is just 1. And we have a to the power of 3 minus 3. What is 3 minus 3? We know it's 0, guys. So a to the power of 1, a to the power of 0 is just going to equal 1 because any variable that we have to the power of 0 is just going to equal 1. So it's 1 times 1, which is also 1. And finally, b cubed. So 1 times b cubed is just b cubed. So we're going to go down here and we're going to go b cubed. So this is our little equation over here, okay? I'm going to move this so that it's a little bit bigger so we can focus on it more. So guys, this is our equation right here. We started off with a plus b squared, and now we have this guy right here. Actually, sorry. So guys, we're finally here with our equation. We started off with a plus b to the power of 3, and now we have our equation over here. So we did use variables within the factors, within the parentheses, so we're going to just leave it as such. You can plug in the numbers if you choose. Now we're going to move on to the harder example. Let me erase this right here. And we're going to start off with a harder example. This example is going to be, so we're going to start off, let's do easier. I don't want to do an example too hard. We're going to do something a little bit more difficult. So I'm pretty sure as I'm writing this, you guys can already see what the difference is. So within the last time, outside of the parentheses, we had an exponent, right? Which we still do, but this time we're going to put one inside as well. I don't want to expose you guys to harder examples so that in the future, when you come across them, it's pretty easy. So a squared plus 3b to the power of 4, right? Um, this one is not too hard. So we're going to start off with plugging our equation into the formula. So k equals 0. 2, right, as I explained last time, is the sum of k equals 0 to our exponent, which is 4, or our n, rather, because there's 2 exponents this time. So we're going to do 4, choose k, is like our formula says, to a squared, because that's like the formula says, to the power of 4 minus k with 3b to the power of k. So as you can see, very easy to plug in our binomial and into the actual formula. So let's go. We're going to start off with the first group, that being 0. So it's going to be 4, choose 0, which is a disgusting 0. 4, choose 0, still have a squared, right? A squared, the power of 4 minus our k, which is, first one's going to be 0, right? Times 3b to the power of our k, which is 0 once again. So 4, choose 0. Now you guys could probably plug that in if you want. Actually, you know what I want to do? I want to just do all of them so we can group them up like last time. So we're going to do plus because it's the sum of, right? 4, choose 1 to the power, sorry, times a squared, 4 minus our k, which is 1 this time, 3b to the power of 1, and so on. I'm going to fast forward this. I think you guys kind of get the gist. I'm going to fast forward this and get to the point where we can kind of simplify and group. Okay, we're at the last one. So as I said from before, right, the number we're going from is from 0, all right, so right here, 0 to, sorry, to 4. So our 4 is going to be the last sequence we do. Drag ourselves a little over here. So 4, choose 4, a squared to the power of 4 minus 4, 3b to the power of 4. Okay, so we're going to group and simplify. Now, yes, this does look long, but as you guys already know, it's really, really easy, so there's nothing to worry about. Just imagine like a sheep in wolf's clothing, okay? It looks scary on the outside, but really, really easy on the inside, or soft on the inside. So we have 4, choose 0. We're going to do this one. So starting off with 4, choose 0. 4, choose 0 is 1, all right? We're going to do a squared to the power of 4 minus 0. Now, this might look like a little bit hard, but it's really not. So we're going to have a squared, right, to the power of 4 minus 0. Now, 4 minus 0 is 4. So a squared to the power of 4. You just multiply 2 and 4. What is that? 8. So it's a to the power of 8. I should probably take out those parentheses. I don't like those parentheses. A to the power of 8. And we have 3b to the power of 0. Now, like I said last time, that is just going to be 1. Whatever it is, anything to the power of 0 is 1. Okay? Now, the next, okay, so what is this right here? It's going to be a to the power of 8. So we're going to do the next one right here. 4. Choose 1. Very, very easy. 4. All right. Now, a squared, all right, a squared to the power of 4 minus 1. What is that? 3. So it's going to equal 2 is equal a to 2 times 3, which is equal to a to the power of 6. So it's going to be times a to the power of 6. A to the 6th, right? Because we got now the exponent over there, times 3b to the power of 1, which is just 3. Actually, no, we can kind of simplify it. We're just going to combine them now, rather like this. So 3 a to the power of 6. 2 more. Yeah, 5. 3 to go. No, how does it matter? Okay. Now, this one right here. What is it? So 4 choose 2 is 6. Okay. A to the a squared to the power of 4 minus 2, which is just 2, is going to be a to the power of 2 times 2, which is a to the power of 4. Easy. Now, 3b squared is just going to be, we're just going to square this value right here, which is 3. So a squared is 9b squared. Okay. So now we're going to bring it down here. All right. And I'm going to zoom out a little bit so this is easier for us to look at. We're going to go over here and it's going to be 6. 6 times 9. All right. Oh, yeah, we can't simplify. It's going to be 54, which is just 6 times 9. All right. A to the power of 4, b squared. Okay. Really easy. Then we're going to go to the next one. 4 choose 3, 4. All right. And I'm just going to kind of fast forward from here just because I think you guys kind of get the point. Okay. So here we are, guys. I'm just going to explain this one just in case. In case somebody out there, like me, does not understand after a couple examples, which is perfectly fine. So 4 choose 4, 1. You guys can calculate that by yourselves, but me personally, I'm not going to right now because I do know it from the top of my mind. A squared, all right, to the power of 0. Sorry about that. Kind of just in my mind there. A squared to the power of 0. Anything to the power of 0 is 1. So we have 1 down here. And then 3b to the power of 4. So like I said, just put 3 to the power of 4. So our number to the power of the exponent we have, which is 3 to the power of 4, this equals 81. Okay. So combine the terms and we have 80. Sorry, oh, that's disgusting. 81. 81b to the 4th power. Pretty easy. Okay. We're gonna add that down here. So we have 81, the b 4th power. Okay. So all that work, and we're here finally, guys. Okay. All that work, and we're finally here, guys. Okay. We're finally here. So this is our equation. Okay. This is the binomial expansion, right? It's expanded. Okay. This is it expanded. Okay. So we have it. So a squared plus 3b to the power 4 is equal to our little equation here. I hope you guys understand this concept somewhat. It is pretty easy. At first sight, this little guy right here might look scary. Okay. Oh, sorry, wrong. This little guy here might look scary, but I promise you, he is not scary at all. Okay. He's very, very cool, and you can work with him very easily. So, if you guys have any other questions, or if you think I messed up or I did mess up, then just let me know in the comments. I can clarify. If you guys have any other questions, leave them in the comments. I can clarify. And see you guys next time.